Thank you, Darcy. I think we're going to go straight into our guest speaker. So it gives me great pleasure to introduce Geoffrey Webster to talk to us today about rubbish. Geoffrey Webster is a chartered professional engineer, graduating with honours from the University of Adelaide, and is the director of a specialist waste and engineering consultancy located in South Australia. He is a member of the Australian Institute of Company Directors and has been awarded an MBA through Latrobe University and has over 20 years' experience in the engineering and waste management sectors. Geoff has held board position with not-for-profit entity KESAB, Environmental Solutions, South Australia's leading not-for-profit organisation in delivering world-class environmental sustainability programs, and the Waste Management Association of Australia. I have it on very good authority that Geoff sat for his last exam at university a few years ago on a Friday and had planned on having the following Monday off before he started looking for a job, which I believe were a little scarce. So it must be a few years ago, Geoff, at the time. However, he received a call late on the Friday asking if he would go in on the Monday for a job interview, which he accepted. Then, after a 3-hour interview, he was offered a job. And could he start tomorrow? Apparently, he said he would like to have the day off. So on the Wednesday, he started work, which was the dismantling of the Osborne B power station. Rotarians and guest, Geoffrey Webster.
Now, I'd just like to highlight that I actually didn't tell him that story, so I'm not exactly sure where he got it from, but I'd hazard a guess to say he got it from my fan club, which is table number 7 over there, which has my mother sitting at it, so that's the scary thing. I'll just get the PowerPoint presentation up and going for you. So look, thank you very much for having me here today, and it's a pleasure to be here. I'm actually seeing a whole lot of people I haven't seen for quite a long time. I've got Don Sarah down here, who's my old under 14A rowing coach. And, you know, there's Raf's partner over there, equally bald to myself. He and I have done a lot of work in the waste industry over a number of years, and so there are plenty of people around here that I actually know, which is a scary thing. Now, I don't know if it's good for them or bad for them, but that's okay. So look, when we start to talk about waste, people start to think about, just throwing into the ground what was done many, many years ago, and just, no one really cares about it. They put it in their bin at home and off it goes, and sometimes they burn it, sometimes they just throw it on the ground off to one side, and that's about it. And look, in some places of the world, that's actually the case. So Heidi and Rob both mentioned about, world peace and the theme that we've got going at the moment. And one of the things that leads into that is about social equity. And if we look at where we are in Australia, we're very fortunate with what we've got, the things that we enjoy. Look at the meal that we're having here today. But in some places of the world, and this is over in Guatemala, this is how they deal with their waste. This is a local stream. This is how they're getting rid of all their plastic. Historically, what they've done in those locations, they've just thrown their gear into the stream and off it's gone, it's biodegraded or whatever it might be, and that's been fine. But now with the way that society is, that just doesn't work anymore. So that then actually brings us back to what we do here in South Australia. So for the waste industry, in SA alone, it's $1 billion industry. We actually then contribute through value-add sources and whatnot over 500 million, and we employ almost 5,000 people full-time. It's actually a massive industry. People don't realise how big the industry is here in South Australia. With what we do, there is then the potential, though, to generate lots of landfill greenhouse gases through landfill disposal. And with what we do through our diversionary activities and whatnot, we actually divert and reduce greenhouse gas emissions by over 1 million tonnes of CO2 equivalent every year. Now, when we start to look at what we do here in South Australia, you say, okay, how big is it? Well, we generate about 5 million tonnes of waste per annum. So it's a massive amount. I'm not going to try and compare it to footy ovals and those sorts of things, but you think about how much that actually is. But when you then start to look at what's happening in the waste sector and what we do here in South Australia, we can then break it down into various sectors and various streams. Of that 5 million tonne, we only have about 800,000 tonnes that goes to landfill. It's still a lot, but we're actually getting a diversion rate of about 83%. So through all the different initiatives that we have around the state and around the country as a whole, we actually get massive amounts of diversion. That's done through what's happening with regards to your green waste bin at home, your yellow bin. Then, of course, there's a residual component, which might be red or purple or whatever it is, depending on what council you're living in. But then there are other sectors as well. We've got various sectors we call the C&D, construction and demolition sector. We've got commercial industrial sector. We have the residential sector. We break it down in the way that we speak within the industry, just because we don't like long words all the time. We just say C&D, C&I, etc. But you can see then with this little graph I've got on the table, I don't know if you guys can see it over there, and I apologise, I wasn't too sure how it's all going to be set up here today. But we've got massive amounts of diversion. We actually divert over 4 million tonnes from landfill every year, and that's one of the things I'm going to be talking about today. So with SA, how do we actually then compare against the rest of the country? And what you can see with this graph, this is trying to show below the line is a per capita amount of waste that is actually going to landfill, and then above the line is the green, which is actually saying how much we're diverting. And then the little dot at the top says as a percentage what level of diversion we're actually doing as compared to everyone else. And you can see from this table that we're sitting about 80-odd%, 85%, 83 in a bit. We're actually far and above any other state. So SA is actually quite proud of what we do in this area. We have a group called Green Industries SA, which is a world leader with a guy called Vaughan Levitsky, who is seen as a champion for waste diversion around the world. So he goes all over the place speaking at all sorts of international conferences and lots of initiatives to try and drive and improve what happens. We actually look to, people come to us and say, what do we do? If you look then at the likes of New South Wales, all these other big states, they're sitting at much lower numbers. They're sitting down at 60-odd%, 50-odd%, so we're actually doing very well. Probably the Northern Territory isn't the best place at the moment. They're sitting down about 12%, but I'm actually involved up there a fair bit at the moment, helping with waste strategy and those sorts of things to improve what they're doing. But it's all about trying to come up to where we are as a state. So within that area, we then say, okay, what are we actually doing with waste? And there's a thing we call the waste hierarchy. And that waste hierarchy is then saying, okay, let's first of all try and set up this avoidance. Let's stop generating the waste in the first place. And if we can do that, then that's brilliant because it doesn't go through the system. Then you work your way through. You go to reduce, you reuse, recycle. And only the last thing that you actually then do is actually send it off to landfill. So everything that we then try and do, and that waste hierarchy has driven a lot of policy here and around the world for many years, it's something that then underpins every activity that people look at. So then, under that sort of system, we then try and look at, what are the key areas? And I do apologise, I'm actually trying to cram a whole lot into a relatively short period of time, so I'm going to whip through a lot of this stuff, and I'm sure there'll be questions or whatnot at the end that we can deal with. But one of those high-level things is about recycling, the reuse of these sorts of products if we possibly can, and that's when you then get into what's called a material recovery facility, or a MRF as we call them. And so I'm actually involved in building one of these at the moment for cities of Port Adelaide, Enfield and cities of Charles Sturt. And this is a general sort of layout about what you can actually see in one of those sorts of facilities. And they're quite high tech. This is a $20 million plant that we're looking at putting in place to deal with somewhere between 20 and 40,000 tonnes per annum. You've got optical sorting systems, you've got trommel screens, you've got picking and plucking lines. We're trying to pull out all these different elements within the waste stream. And so this little flow chart here, and I know it's too small to read, but this is identifying the various types of materials that you put into your bin at home and things that we then try and pull out. So effectively, it's not quite unscrambling an egg, but it's along that same line. So everyone throws it in together and then we try and pull them out. So by doing this, we can then try and get levels of diversion out of your curbside bin that sit up over 80-odd%. Now, it depends on what you throw in there as well. So if you're throwing rubbish in, there's not much we can do with it. But as long as you're getting the good stuff in there, we'll be pulling it out. So a lot of bin audits are done, and we actually dig through your rubbish bins to work out what you're throwing in there. We track it, we do bin audits, we might get 100 bins at a time, and we'll go through the whole lot to try and understand what you're putting in there and what's been done and what's been done not so well. So this is actually just a little bit of a video of an optical sorting system. And what you're going to see here, this is a high-speed belt. It's got lots of little things on there. And further up the line, there's a computer scanner that's actually looking at the materials that you have on this belt. And then you'll see little air puffs that'll come through and knock some of the material off into a different area. So that's a way of actually splitting waste streams, and that's what's in this MRF. So that's the speed it goes. You see how there's a can flying off, and up the top, you're about to see another thing puff up in the air. That's what we then integrate into these systems that are handling your rubbish. So if I then take the next step down and I look at what is another element within it, we start to look at the green waste stream. And so within that, we start to compost the material. And a lot of you will know what a compost is. You might have them going on at home, and really in general, you know, it's just then done on a bigger scale. You've got big pads that sit out there. You've got long composting lines, and all your food organics, all your green waste, etc., they're all going into this area. And we munch it up and we do all sorts of things, and we come up with a nice product at the end. So there are two groups, primarily in South Australia, that are dealing with that, Pete's and Geoffrey's. But even with those guys, they then have specialised systems that then deal with it. So this is the Ross system, which is used by Geoffrey's, and this is something they integrate into how they handle their organics to then try and clean things up. So I'll just run another little video for you on that one as well. And I'm trying to cheat by doing this, by doing lots of videos, so I don't have to talk as much. So with this is called the Ross. So what they do is they get their composted material, they pick it up, they put it into a big hopper, as it's called. And so with that hopper, it then actually just helps to actually feed the material into the overall process. It then goes over disc screens, which then start to have all the heavy stuff drop out. And you can see at the bottom there, it's relatively clean, whereas at the top it's not. And it tries to get those big products, etc., flowing through the system. Once it's actually gone through the system, that's then showing the actual the underside of it with things dropping through it. With those elements that are not as good or not clean, they go out the back end. They'll then get crushed up, shredded and whatnot. They'll get put back into the whole composting operation. It has a vacuum system on there. So as you're coming through, the lighter stuff will float across the top. It actually gets sucked up and off out of the system. We then have people who go through, pick and pluck it, and they will then try and decontaminate. Because the worst thing you want is around all the vineyards and all the fields where this stuff goes, you have bits of plastic and whatnot that stay in there. And that just stays over time, doesn't disappear. That's a magnetic separator that comes through, and then what it does is it goes onto a belt where it's then spread out nice and fine. And once you do that, they actually now have an X-ray machine. So that X-ray machine is doing something similar to the optical sorting system, and it has a system whereby the stuff goes over the top, the X-ray identifies it, and then you have puffs of air that are coming through and then knocking the big materials out. And so with that, you can then get a nice clean product at the back end. So again, you can see this little puff of air comes through, knocks that little square box out of the way. So again, it's about cleaning it all up, it's about making it nice and neat and making sure that everything works well. So once we move on from there, we then start to get into the C&D sector, the construction and demolition sector. Within that area, there are a couple of different things that you generally be looking at. You can be looking at concrete crushing and those other big things, but another pretty cool element is when we start to look at energy from waste. And there's a group in South Australia called Resourceco, or Suez Resourceco. They have done some excellent work in this space, and so I'm just keeping track of my time with my phone here, so I'm not taking calls as we go through. And so these guys have gone and done some really great stuff. There are lots of technologies that we can use in this space. There are anaerobic digesters, there's mass burn incineration, there's process engineered fuel, there's plasma art, so lots of technologies. When we start to get into some of these things, you start to talk about hundreds of millions of dollars potentially in their construction. We don't have any of the big units here at the moment. They're building some over in Perth at the moment in Kwinana and other places like that, and they just put basically everything in there and off she goes. But we've got some guys who've done some really good smart stuff. This is, as I said, Suez Resourceco. They've got and developed a plant which is looking at, or which does, generate process engineered fuel. This then goes into Adelaide Brighton, and they can then burn the material off. And this is actually a quick little video of the inside of that location. So this is all construction demolition material. So it's your plastics, it's your woods, it's all of those types of things, all mixed in together. But at the same time, we're trying to put out the steels and other elements that can't be burned as well. And this then goes through what they're doing inside. So just a second ago, you would have seen some mist coming from the top. That's actually a dust suppression system which they incorporate. You can see the type of plant and equipment that they've got operating inside of this area. And Don Serra would know all about this because he was probably generating half the material that went into there at one point in time when he was in the building game still. So all this stuff, it then gets crushed down, shredded and whatnot, goes through all these different conveyors, trommels. It all gets fed out and it comes down to create the fluff. So what that guy's holding right there, that then gets fed into Adelaide Brighton Cement, and they use it as a fuel supplement. So what we're trying to do then is prevent the use of gases and other elements like that, these non-renewable fuels effectively. We can then get better value from that by using these sorts of process engineered fuels to then lead into what they do. So there's a lot of smarts that go into it. There's a lot of technology. And as I said before, a lot of people think about waste and rubbish and you just throw it in a hole somewhere. This is the type of technology that we're using in the waste industry to try and make sure that we are promoting social equity in what we do. So it's not just about now, it's also into the future. So then we start to talk about the residual component. What happens in that space? And everyone then says, oh, it goes to a dump, goes to a landfill, and we get rid of it. But what's part of that? You know, in South Australia, for example, we actually don't let that happen. We take everything to a transfer station first. A couple of rural areas might do something different because it's a little bit harder for them. But in Adelaide, no material goes to a landfill without going through a transfer station first. The rationale behind that is it's another opportunity to take potentially recyclable material out of the waste stream. And so there's additional cost, there's a significant additional cost that is in place because of that, but it's one that we as a society pay to try and promote the diversion of material from landfill. Now, once you start going to a landfill, you start to bring in all sorts of environmental control systems. We have lining systems, we have gas control systems. We try and minimise anything which actually can get out into the environment. And what we also then do is we monitor everything. So we then look at, you know, what's happening to our groundwater. Is it getting contaminated? If so, how do we stop it? How do we prevent it? How do we mitigate potential impacts? Are there odours that are getting out? Is there litter getting out? What's actually happening in that space? We can track gas. We walk over the top with what's called an FID, or flame ionisation device, a little sniffer, as we call it, because that will actually identify if there's gas coming out of the surface. It'll flash blue, basically, and it can take a reading as to what sort of gas levels we've got at the surface of the landfill. So again, we're tracking all of these things to try and make sure we mitigate potential impacts. So landfills, you would have seen a couple at the very start. This is what they're looking like now. They're relatively neat. You compact it well. You make sure the airspace is used effectively, and it looks good. And so I have here a little one. This is one I actually just did up in Darwin. This is the construction of a new landfill cell. So a little video just showing how that all starts to take shape and develops over time. We don't need that volume. I don't know if I can get rid of it. Oh, there it was going. There we go. So this is just the general initial excavation. With this one, we actually do a dewatering system underneath the landfill to make sure that we have separation between the base of the landfill and the groundwater system. So we've gone through, we ripped that all out, then we start to develop a bit of shape around the outsides. So we actually had to break because this one then had the wet season come through. We can't construct during the wet. But as you then come through, you'll see we now are forming the sides, and in a second you'll see us start to place some lining systems at the far end of the site, and we work our way through. And as we're working our way through, so here's the clay liner coming down. On top of that, we then place a geotextile, and then we put an HDPE, or high density polyethylene plastic, over the top. So we've gone through, you've got layer upon layer upon layer of environmental protection system. And on top of the HDPE, we're putting down a leach-shaped drainage aggregate, so gravel basically then to allow for all the nasties, all the liquids that are in there to be collected down to a low point. So in that way, again, it's about trying to minimise pressure on the lining system, take it all out as best we can. So this is a new landfill cell that'll last probably about 6 or 7 years for Darwin. It's a 45,000 square metre landfill cell. So that's just one cell of what they do out on that site. And that's taken probably about 8-9 months to construct. That's all down to a minute and a bit in a little video. So that's what's going on in a landfill, and it's not what a lot of people know about. They don't think about that, and that's just the base system. That's nothing to do with it. It goes over the top. We'll do that over the top. Again, I'm involved at the moment for the next stage of that with stage 3-4, putting a cap over the top. And so with that cap, we then effectively put down, well, in this instance, we're going to put down an LDPE, so low density polyethylene. So that has a bit more flexibility because the landfill over time will settle down. So we need to understand the mechanics behind the landfill, the way it works, the way it operates, to make sure that, again, we're going to maintain that environmental protection system, not just now, but over the next 30, 50, 100 years of that landfill life. So with it, we're actually then bringing in lots of additional technologies because there's still value to be sourced from within the landfill. We can collect landfill gas, for example, and with that landfill gas, we can then power households, we can put it back into the grid, we can do all sorts of stuff. So what we'll then generally do is put in a network of gas collection systems, and they will then suck gas out. So it's under a negative pressure. We'll actually suck the gas out from the landfill. We'll put it through a generator system, and we will then go and, as I said, put it back into the grid. So there are other technologies as well. This is something whereby with the landfill, the waste that comes in, we run over the top of it with a compactor because you squish it all down to get into the area. We actually then track it using GPS to identify where is the landfill compactor going up and down as you go through. Is it settling as it goes over the one spot to make sure you get maximum efficiency at a placement of that material? We are also using drones to do flyovers to make sure, or to do surveys to understand what's happening in regards to settlement on the site, to see where materials are going, how we're utilising the airspace. These are the sorts of just a start of what we do. We have weighbridge systems that track pretty much every tonne that comes into these facilities. We can track it back to producers, to how we're actually handling materials on site. There's so many different technologies that we're using in the waste space to try and make sure that we deliver on best practice here in the state. So where are things going? This is what that little triangle that we had at the very start, the waste hierarchy, is transforming into. It's called the circular economy. And what it's trying to do, because that first one's very linear. Things come in, they get handled, they go off, and that's it. They're used once. Whereas now they're looking at how do we use things again and again and again and again, rather than just that one-time use. That is the focus of where a lot of the discussion, a lot of the planning, the things that you might hear within councils or within government, this is what it's all looking at. So again, I can't try and go into every single little piece of that because it's too hard, quite simply. But that's the principle of what we're trying to do. So with the material recovery facility that I'm building at the moment, one of the things that we're looking at is how do we actually take the products out that will then go out and be manufactured into something that the councils themselves will actually purchase that then feeds back into the system. So that way you're actually going to be reusing the materials that you've thrown into the bin. That's the principle of the circular economy. So there's a lot happening in this space as well then within the government, trying to drive this and trying to make it all happen. The government regulation is particularly challenging in a lot of areas. I don't know if you've heard, but there are waste export bans. So I was talking before about some of that linearity. The federal government have come out and gone and said, well, come this time next year, you're not going to be allowed to export plastics overseas. And that's trying to stop dodgy operators, right? So that's all fine. But there are some instances where it's actually probably the best thing that we can do with it at the moment. So it's a challenge. And what's happening is the Australian economy is changing because of those bans. We are looking to try and create new industries here locally to then try and deal with those materials. Otherwise, they're going to go to landfill. So that's the real pressure at the moment. With plastics, with papers and cardboards, tyres, when they're shredded, etc., they might currently be going off to kilns. None of that can happen anymore. These are the things that need to be managed and need to change. There's also the increased costs that are occurring due to EPA levies. So currently we have an EPA levy that sits at about $140 a tonne. Current disposal costs are sitting about $180 a tonne. So that's how much the government is taking and driving up the price to drive all this and then pay for it all. So of that money then goes into a levy fund, and that levy, half of it goes back to the government in general revenue, and that half then stays to fund the likes of the EPA, of Green Industries SA, and to fund projects to, again, try and increase the diversion of waste from landfill. So I can see that I've got my little security guard here right next to me, so that's fine. And look, it's actually almost perfect timing because this is my conclusion. There is lots happening in this space. This is just a snapshot of what we are doing. But you can see that with that, the industry itself is acting progressively and very actively to try and then mitigate those impacts and to try and manage these materials in a responsible manner. Thank you very much.
Thank you, Geoffrey. You mentioned Resource Co. and I actually have been down to their their site, and I know all the fluffy stuff they go and burn at ICI, Adelaide Brighton, but all the hard gear, the old concrete, everything else, I gather that goes into a lot of other things like roads and things. Perhaps you'd like to just comment on that?
Sure. So that's the bricks, the concretes, those sorts of materials. They'll crush it all up. They'll make it into aggregates. They'll then actually reissue it as new concrete. That's how far they go. They put it down as hard stand materials. It's used in lots of different endeavours. And there are a couple of different groups that do it. You've got Resource Co, you've got Adelaide Resource Recovery. Together those guys handle the majority of the C&D waste that's generated within South Australia.
John Hunter.
Thank you, sir. Thank you, sir. I really enjoyed that talk. However, one of the things I notice is so much glass these days, and there's lots and lots of bottles, jam jars and pickle jars and all sorts of things which you get no 10 cents back. I think that you people have got to work on the government to charge a 10-cent levy on anything that's glass, because if that gets smashed or broken, it makes a hell of a mess, causes all sorts of problems. So please work on glass that's not collected like ordinary cool drink bottles. Thank you.
Well, if I might address that one, the government is currently going through a review of the CDL system, and they're looking at whether or not they potentially expand it to include things such as wine bottles or other areas. And if I look at glass, such as the jars and whatnot that you're talking about, from the material recovery facility, I have a little area for non-CDL glass. And with that, I'll actually pull that material out. I'll then clean it up. And then we're looking at the likes of Downers, look at going back to O&I glass, Aurora, and we reuse the materials in those areas. So we can actually generate a revenue if it's clean enough to go to OI and to Aurora. And with the likes of Downer, it costs a little bit. So we are actually dealing with those materials as well.
Laurie Lewis.
Yeah, I found it very, very interesting. What actually goes to landfill? Because there's so much stuff is recycled at the moment. I'm confused.
Well, it's only about 13% or 17% or whatever it is. But with those materials that go in there, there are still food organics that go to landfill. It's not a massive proportion, but in your household bin, and again, I mentioned about us diving into bins, we do the waste audits and we break it down what's in that red bin. So there will be instances whereby, food waste is mixed in with some plastics, for example. And when that happens, there's nothing we can do about it. The plastic's too dirty to actually send anywhere to get recycled. The food's mixed in, we can't pull it apart. That material will go to landfill. The percentage of food waste still going into the general waste bin is about 40-odd%. And there'll be people, Simon might even know the number better than me, but I think that's about the number. But it's in that sort of range. And so that's actually seen as a massive target by the government. There's a recent strategy or consultation paper, I should say, that Green Industries has put out about food organics and trying to get them out of the waste stream. But there's still some papers and whatnot. So again, if I've gone and put food waste on my fibrous material, my cardboards, whatever, I can't use it because I can't recycle that fibre. But at the same time, I could actually potentially compost that material. So your pizza boxes, etc., when you've got the greasy stuff in there, it's better actually put that in the compost bin rather than the recycling bin because they'll then reuse it, whereas the guys at the MRF, they can't do anything with it. So there are lots of plastic. So as well, something I've seen over the last 15 years or so, the amount of plastic in the waste stream is just massive. And so the government has just gone and banned single-use plastics for that very reason. So again, it's all about those drivers.
Stephen Noble.
Yeah, thank you. I think all of us here found that a very interesting and informative address, and we're all party to creation of this waste that you have to deal with. I've got a query in relation to my knowledge of the wine grape industry in particular, where, and we have vineyards in our own family business, but I know there'd be tens of thousands of tonnes of permapine posts treated with arsenic, cannot be incinerated, and right next to those tens of thousands of tonnes of posts, which is scattered over probably hundreds or if not a few thousand properties around regional Australia, you'll also find another pile of black polypipe. I'm just wondering, to me, it's just a bit of a travesty that these amounts are building up on properties. They can't burn them. Disposing them is very difficult. So I'm wondering if you'd like to comment about that, because I think a lot of people don't realise that we have this issue in regional Australia.
Sure, CCA posts are a massive issue. And if you go back probably about 10 years or so, the landfills wouldn't take them. So I was actually operating the Inkerman landfill at the time. So I ran all of Cleanaway's landfills here in South Australia. And I got the first approval for the receipt of CCA posts within a landfill for disposal. So a lot of the time, I find that a lot of people won't get rid of them because it costs so much. Transport is expensive because you can't pack them neatly. Sometimes I do a really good job of stacking them up and whatnot, but a lot of the guys, they have them lying around the place, getting them into the truck, moving them around the place. A lot of them, they'll break. So generally, and again, you probably know this better than me, but 8-foot poles in length, they'll snap off at ground level, which gives you a 5-foot section and a 3-foot section. And how are you picking up these little 3-foot sections of wood? It's a hassle for them. So I find what they often will do, put it off to one side, and then it's convenient. They just leave it there because it's expensive to get rid of it. So you are right, we can't burn them. Shredding them is no good either for transport because that actually then helps mobilise the contaminants that are within there. At least over time they've had a chance to, it leaches out with the rainwater and whatnot. CCA is not an easy answer. And so that's why, I don't know about CCA production, but I think that that's a material that probably won't keep going forever and a day just because of the nasties that are involved in it and the fact it is a linear type of approach for those units.
Thank you, Geoffrey. I'm sorry, but that's it for questions. Otherwise, I'll get shot by our president, and I know what women are like. Geoffrey, thank you very much for your discussion today. Fantastic. And on behalf of the Rotary Club, a donation, I'm going to give you the sort of certificate, which says that a donation will be made on your behalf to mitigate and contain the COVID-19 pandemic and to support efforts to eradicate polio worldwide. So thank you very much, Geoffrey, and I'm sure there's a lot more rubbish left in this man.